Duty cycle is nothing but a reference which is going to have some set of requirements for your vehicle systems and for also for your vehicle subsystems as well. As per this NATC, which deals with the duty cycle related to your system or subsystems, these have been they ensure that these duty cycle have been considering the customer use cases. Okay, how the customer is going to use in the vehicle at various conditions, various scenario, the drive pattern basically, and they will also ensure that based on that DOEs or the test cases, whatever they are preparing before they launch the vehicle to the market, they ensure that the customer success is there based on the duty cycle what they have been evaluated. And there are certain requirements which it will also this duty cycle helps to optimize the products. So the first requirement here is we need to identify the product boundary conditions with respect to the cost point of view, what the customer really wants, and what is the aspects with respect to the warranty, what is the time to market schedule. So this is also very much important uh, to consider the requirements. And the next requirements is we need to define how the product will be used. So when we have seen different type of category, M category, O category, and we have a lot of various classifications with respect to the vehicles in two-wheeler, three-wheeler, four-wheeler, and commercial off-highway vehicles. And here it's very important how we are going to define the product and how that particular vehicle will be used, including the customer profiles. So that's where we also do a lot of tests like Indian driving cycle, European driving cycle, federal test procedures, Europe test cycle. So we do a lot of things, and where based on the customer drive pattern, we test before we launch the vehicle to the customer, and based on the road roughness. So we also do different type of tests like city condition test, highway condition, rough road condition, accelerated durability condition. So a lot of conditions where we test the vehicle and various different climatic conditions. That's where we also do some of the hard climatic, some of the things like related to the summer dryer, winter dryer, especially for some of the electric vehicle aspects where the summer dryer is very important to ensure that the thermal runaway, or they also try to understand what is the range that they are going to get during the summer related thing, because the one problem with respect to the electric vehicle is in summer uh, it is very difficult for you to charge because the temperature is also going to be higher, especially when it is during the afternoon time, uh, when the vehicle is in very hot places like Jaisalmer or Kadapa, where temperature is on the higher side. Sometimes what happens is even the charging also becomes difficult, and even if you charge, sometimes what happens, the range you will not get the required range also. So these are some of the things for which relevant to the customer use cases or the driving pattern or different climatic conditions you need to prepare the duty cycle. So that's very much important. Uh, and here considering the duty cycle, here you are also going to correlate to the test operations, which will account for the real world inputs like repeatability. So we are going to do the tests in both way, like in a control testing environment and as well as in the way where we test the component along with the vehicle in an open environment as well. And again, we have seen the RLDA where we measure the component performance during operation using RLDA, and even we also measure some of the vibration related aspects at various locations in the vehicle related to the mechanical structures like suspension parts, uh, where the vibration is tend to be more, and even for the chassis frame. So we used to try to at various locations we try to measure what is vibration level, and we also compare that particular vibration into the overall overall transfer frequency, and we will see whether the frequency level is within the limit or not. And we are going to use the already information for even for the model validation in the computer simulation environment over the duty cycle. And this will help. This duty cycle will also help to further optimize the product, and this also helps for analyzing and reducing some of the time and cost with respect to the test cycles, which we don't need to repeat again and again. Okay, and again, it will also help to reduce the cost of repeating the test with respect to the vehicle at various conditions. And on the other hand, the definition of a heavy duty vehicle segments and duty cycles are, with respect to the market are also very much specific. And we have separate vehicle and components in group with similar usage and fuel consumptions and various conditions. We also do the duty cycle. And this duty cycle will also enable the use of specific duty cycles and the CO2 emission target for each segments. Okay, you also have the different vehicle category for which you have different emission norms targets for the conventional vehicle. So these are some of the examples for EVs heavy duty vehicle segmentation for GHG regulation. So you can see the class 2, class 3, class 4, class 5 category, class 6, class 1, class 8, where it is divided based on the weight. Okay, so the weight is given in pounds, LBS basically, and it's basically applicable for urban multi-purpose vehicle having different classes, and you can see even you can see some of the examples where it is coming under high roof category, mid roof category, and low roof category, and there are some category for a tractor application as well, in which you can see in the picture you have even for a bus application, tractor application, the sleeper cab application, the truck application, even for some of the concrete truck where since it's shape of even for this also you have the regulations for which you can update a duty cycle. So this is the heavy duty vehicle segmentation for fuel consumption standards for India and Japan. So it's for the three applications we are going to see here. First one is going to be for a rigid truck, second one for a tractor trailer, and third one for a bus, where it is been categorized based on the gross vehicle weight. You can see the various different weights and what is the configuration that we are going to have for an axle. Okay, even that is also been mentioned as a part of the standard for rigid truck, tractor trailer, and also for a bus. And again, we also have some requirements for the tractor and the rigid trucks, and even for a bus where the gross vehicle weight should range between so and so values, considering the different dimensions, and based on that you also configure what type of the configuration that you are going to use for your axle. This is the graph showing the comparison between the various countries, which involves Japan, China, US, and the Europe, where they use different heavy vehicles related to tractors, trucks, and delivery vehicles, and some utility considering utility vehicles as well. Against the gross vehicle weight, what is the gross vehicle weight that they have in terms of tons? You can see different country having different vehicle application. They follow the different gross vehicle weight. Okay, you can see ranging between 5 to 50 tons. Okay, and it also varies depending upon the country usages and also the purpose for which the vehicle has been used basically. So here, considering the duty cycle, it should represent the real on-road heavy duty vehicle operation. So here the definition of representative duty cycle for heavy duty vehicle is challenging. because of variety of applications. The main objective with respect to the duty cycle design is to give a realistic fuel consumption values. What is the fuel consumption that we are going to get for different vehicle variants, basically? What we have seen with different various classes, basically. And the definition of the duty cycle is also dependent on various among other factors, which involves the vehicle fleet technical specifications and what type of road we are going to use. Is going to be an urban road or a highway or a regional road? What is the speed limits? What is the topography of the vehicle? What is the traffic conditions? And again, this duty cycle can also be categorized into two main categories uh, based on the actual speed versus time and also the target speed versus distance. So this can be categorized like with respect to what is the maximum actual speed with respect to the time and also the target speed what we have been targeted as per the specification with respect to the different classes of the vehicle and what is the distance for the particular vehicle. That's why even when you do some of the trial like city durability test or gross highway durability test or accelerated durability test or rough road durability test or uh, composite durability test, whatever you do, you have some target, right? Whatever is the target speed or what is the speed, and even you also have some of the kilometers being fixed for that as well. That's what the distance comes into picture. So some tests will cover for 50,000, some tests will cover for 1 lakh, some tests will cover for even 10,000. Say for example, when you're taking some of the two-wheeler application, uh, the kilometer might be lesser. So it also varies depending on different category of the vehicle based on which the duty cycle is being prepared basically. And again, this is the way different kilometers, what I was telling, 10,000, 40,000 or 1 lakh or the different kilometers, that is for a complete vehicle. And there are some design verification plan that normally we do what that will also be specific for a particular component alone. Say for example, the brake system or a steering system or a suspension system or a frame. Say for example, if you are reducing the weight of a frame from x to delta x, okay, x minus delta x, maybe if you are reducing 2 kg weight in a frame, for which you are going for a duty cycle or validation. So based on the application, based on the change content or a change matrix, you also do a lot of validation in specific to the particular change. It can be related to a change of a frame or a suspension, or even if it not it cannot it can not only be with respect to a design aspect, even can be a change of source or a supplier, even for which you do some of the test or a duty cycle. Okay. Uh, Let us go into some other topics related to. We know this WHVC, which stands for World Harmonized Vehicle Cycle. This has been developed under the United Nations UNEC, which stands for United Nations Economic Commission for Europe, for harmonization of the vehicle regulation. And this WHVC is based on the data from the trucking operations in a number of countries, which includes Australia, Europe, India, Japan, and US, and it's been designed to cover a wide range of heavy-duty vehicle driving situations. And this WHVC consists of three segments: an urban segment, which is going to have a transient stop and go driving conditions, and the second one is going to be the urban segment that will incorporate higher speed, and finally you have a motorway segment where you have a steady state cruise driving condition basically. This WHVC is going to have three segments: urban segment, rural segment, and the motorway segment, based on the stop and go driving or higher speed and steady state cruise driving conditions. Basically, this is the time based scenario where we follow the cycle for a world harmonized vehicle cycle, the time versus speed. That's what we have seen. There are two conditions. One is actual speed versus time, and then the second will be target speed versus distance. So first we are going to see the actual speed versus time for a WHVC. And again, I told you it is divided into three aspects. One is urban, rural, and highway, where the velocity is going to be higher uh, when we move from urban to rural to highway. See, here the urban speed is average 21.3 kilometer per hour, and the rural is given as 43.5, and for highway it is 76.6. You can see this is a combination of these three different segments. First one, you go for a urban category where you do the test for 900 seconds, considering you are going to cover a 5.3 kilometer distance. Considering the speed limit, you can see the speed limit here. This is average speed. Okay, when I say average speed, it involves the minimum speed to the maximum speed, and also with respect to the different uh, kilometers that has been covered here. And you can see the driving. We can see the pattern here for a urban and a pattern for a rural. Where in the case of rural, the speed is going to be 43.5, which is covered for 5.8 kilometers, covering a time of 481 seconds basically. So this is 481 second, and 900 second, you can see it at 900 second. So it's going to cover 900 seconds here. And the last is the highway part, where it is going to cover 419 seconds, covering 8.9 kilometer with a speed of 76.6 kilometer per hour. For this is the one which we follow with respect to time for WHVC. Examples where average speeds are lower in India where when compared to other major markets. So that's why even when you compare the Indian driving cycle with the European driving cycle or the federal test procedures, the average speed in India what we follow is less when compared to the other markets or other country. Uh, and again, the speed what we are referring is average speed. You can see the dots for in India. You can see the average speed is lesser when compared to the other countries. Okay, this is for segments related to the tractor application. Um, and again, different study has been done for a different country, and you can see the different vehicles running in different places in India itself, where the average speed has been taken based on the national highway, what has been the route Delhi to Bangalore, Delhi to Mumbai, Delhi to Chennai, Delhi to Kolkata, Mumbai to Chennai, Mumbai to Kolkata. So this is the average speed that they have for India for this particular segment of category. And this is what we have seen for WHVC. What we do, this is basically we try to understand what is the fuel consumption that that we are going to get out of this trial, and basically we optimize based on that. And the next one is based on the distance. That's what we have seen, which is the second part with respect to the duty cycle. Distance based target speed cycles. It is for the Europe related aspects, like where we have seen the distance versus speed. And you can see the target speed is being set, which will result in the speed profile depending on the vehicle performance, the driver model. And this duty cycle is defined as a routes, which is the road grade profile and the desired target speed as a function of distance. This is what we have seen. And again, uh, based on this, we can also try to understand the vehicle performance with respect to the speed, and then what is the fuel consumption that you are going to get, and what is the braking later aspects also you can also evaluate based on that even say for example tire life. Okay, you can also measure some of the tire wear, the pattern of the tire wear after completing so and so kilometer. You can measure the tire wear using your depth gauge meter, and what you can do is you can compare. You can also extrapolate the wear into what is the initial wear at the 0 kilometer, and what is the wear at various interval, maybe 2000, 4000, 6000, till the tire life. The tire life, say for example, the tire life can be 40,000. If the tire life is going to be 40,000, which is going to be the warranty. So based on some extrapolation value, what you're going to get, if in case if you're going to measure the wear up to 20,000 kilometer at an interval of 2000 to 2000 kilometer, what you can do is you can also extrapolate that with respect to the wear pattern, comparing the initial wear to that of the 20,000 kilometer wear, and you can extrapolate whether is it crossing beyond 40,000 tire life, or is it coming below the 40,000. Based on that, you can also try to improve some of the performance aspects as well. And also those things also based on some of the other aspects, like even the rolling races, and those things also comes into picture where you can also measure those aspects as well. This is the European regional delivery and long haul cycle basically. Again, here also we're going to cover the distance versus speed. I can see for a regional delivery cycle, you can see the pattern, driving pattern, and again you also have the different gradability, percentage of gradability. The slope is basically 5% here maximum, and even for a long haul cycle also you have some slope. Okay, so the next important thing is ACEA regulation. Basically, this is also coming under some of the topics where it represents that the overall data. Basically, ACEA stands for Automotive Regulatory Guide for European automobile manufacturers, basically. Sorry, Automobile Manufacturers Association. Okay. Automotive Regulatory Guide of European Automobile Association, basically. Manufacturer Association. It is basically the regulatory guide related to the European Automobile Manufacturing Association, which gives us a guideline for the long haul over cycle for the long haul cycle for the Europe application. So you can see the map where this has been taken with respect to the various routes, basically, which represents the various routes the various locations of Europe country, where they have taken the long hard road network based on the statistics whatever taken. And here next they are going for a measurement of slopes and also the speed profiles on the specific routes what they have identified. Say for example, it can be greater than 10 kilometers, and they are going to compare the speed and slope characteristics with long haul cycle, and they are going to make adaptation if they need actually. This is some of the duty cycles for engine related certification for CO2 wood harmonized. You have two things. One is wood harmonized steady cycle and stationary cycle you call, and wood harmonized transient cycle. Transient cycle is noted as TC. Stationary cycle is noted as SC. So you call WHSC for a stationary cycle, and for a transient cycle you call as WHTC. And again here the time, speed, and again with respect to the here we are also going to take for a torque into consideration when going for a CO2 certification for engine related aspects. You can see the engine speed, RPM versus torque. This is for a 12.8 liter Euro 6 engine, where the bubble size and color it represents the fuel consumption share of the area with respect to the engine map. Okay, so the bubble water is mentioned. Okay, so this represents the various fuel consumptions. Uh, okay, these are more adaptation of the existing cycle that is very much essential. The tractor engines in US have the limits over the ACT state cycle. ACT stands for supplemental emission test. Okay, supplemental emission test for phase two. The supplemental emission test weighing were been revisited to reflect for a better low engine speed highway operation. You can see the graph again, speed versus torque, where the bubble size and color it represents the fuel consumption for a phase one. This is for a phase two. For a supplemental element emission test that has been kept a tractor application. At a higher weighting of lower engine speed rate is going to reflect a better long haul application again here. I was mentioning about WHSC, which stands for World Harmonized Stationary Cycle, and what I was telling central emission test cycle. Those have been mentioned here in X and Y axis, considering the kilowatt hour, what is the consumption that we are going to experience. You can see the back-to-back comparison with respect to World Harmonized Stationary Cycle and also with respect to the transient cycle. So the comparison has been done with 26 different engine maps have been simulated here, and these were used to estimate the correlation coefficients between the back-to-back comparison. That's what I was mentioning between the WHSC and ACT, and also the comparison between with respect to this, with respect to transient cycle, and also the federal test procedure. Basically, FTP stands for federal test procedure, and you can see the comparison here. Uh, you can see the transient which is going to have the higher value when compared to that of uh, the transient cycle at a particular uh, value of CO2 per kilowatt hour. You can see, and again, this will also vary with respect to the other condition, other pattern as well, drain pattern or the duty cycle what I was referring in the previous slides. Basically, this is a better test procedure for a light duty vehicle. So similar to the last, what we have seen three phases. Uh, Here also you have three phases: cold start phase, stabilize phase, and hot start phase. With respect to the various speed and also the time. The first one is going to be the cold start phase, stabilize phase, and hot start phase. So you are going to follow this test cycle. So in the case of first one, what we have seen is urban cycle, rural cycle, and highway cycle. Similar to this, for a word harmonized vehicle cycle, for a light duty vehicle, you have three phases: cold start phase, stabilize phase, and hot start phase. And so this is for the Europe light duty vehicle test cycle, considering the speed versus the time. European driving cycle and the new European driving cycle. So where you can see the speed comes up to 120, whereas in India, the average speed is 90 km per hour. So here it is, we consider maximum is going is 120, whereas in ATP it will be 140, 140. In US they follow. Uh, these are some of the summary of a light duty vehicle with respect to the various characteristics like distance, total time covered, idle time, average speed, average driving speed, maximum speed, average acceleration, maximum acceleration for the different time, different driving cycles basically, new European driving cycle or European driving cycle or the Europe Commission. Just just give me a second. You just want to understand what is that ECE test cycle. I think it's also coming under urban cycle. It's also called as urban driving cycle EC, and it this is basically emission test cycle. Okay, it's emission test cycle, and you have various regulations. You have something R49 or EC15, and the best it involves like 15 indicates a 15 mode steady state or different state different modes that the particular number is representing. Okay, let us see the comparison here. See, the value is much more higher with respect to all these characteristics for New European driving cycle. Okay, even with respect to distance or a total time or a average speed or a maximum speed, acceleration with respect to average or maximum. You can see the value is high for a New European driving cycle for light duty vehicle application. So those are most of the European countries, means all the European countries they follow this NEDC cycle. Even for some of the applications, what we follow, we compare between IDC versus NEDC, which is on the highest high side, where with respect to various characteristics, you can see the values is on the higher side. And again, you also follow different things like, so for example, here you go for a 4 repetition of EC15 followed by 1 European driving cycle, and you are going to calculate. You follow different combination based on the calculation what you have based on the particular vehicle. And this is the European, sorry, this is the Indian driving cycle. Or what I was telling here, you go with the maximum of 90 average speed. Maximum speed is going to be 90 km per hour, and the acceleration is going to be 0.83 meter per second square. Maximum deceleration is going to be 1.38 meter per second square. This is the modified Indian driving cycle. You call this as the border stage, and what we have in IDC for a four-wheeler application. So this is what for a four-wheeler application. At the maximum speed is going to be uh, 48 km per hour, but this is the one what was the initially, but this is a modified version basically for Indian driving cycle. Okay, so these are the things that we have put various different duty cycles, driving pattern, driving cycles, and we have seen the WHTC, WHSC, SET, and the different like EC, European driving cycle, New European driving cycles with respect to the gross vehicle weight, etc.